Section A5, Solving Polynomial and Rational Equations. So first off, how can we solve polynomial equations? We can solve them by factoring. We can use the square root method, x squared equals n, or blah squared equals n. I skipped complete the square, although that is a method, and then the quadratic formula. So when we factor, we rewrite things in the standard form of ax squared plus bx plus c equals 0. If a isn't 1, we're going to have to do grouping. We set each factor equal to 0 and solve. So pretty dippy problem. I add the opposite of 3x minus 6 to the left side. I factor, I set equal to 0, I solve. Pretty basic Algebra 1 stuff. Another Algebra 1 problem. What am I going to do? I have to negate 7x minus 6. I notice that a is not 1, so I have to do 5 times 6. I didn't list all the factors. The minute I got to 2 and 15, I knew that's what was going to add and give me 17. So I inserted negative 2x and negative 15x. I grouped. 5x minus 2 became the shared factor. What was the 5x needing to make it a negative 15, negative 3? And then I solved. You should be able to do that in your head. I would have just said add 2, divide by 5. You don't need to show these little extra steps. That's just for you all that are maybe a little brain dead during the summer. The second method, x squared equals n, or the square root of blah, blah squared, equals n. How do you solve x squared equals n? Well, you could have factored it, but we namely take the square root of each side and plus or minus the numeric. Blah is equal to plus or minus whatever the numeric is. So x squared equals 7 becomes x equals plus or minus root 7. Blah squared equals 9 becomes blah equals plus or minus 3. I have to use the additive inverse, and so it's now 4 plus or minus 3. So my answers are 7 and 1. Blah squared equals 11, so blah is equal to plus or minus the square root of 11. I have to use the additive inverse of positive 3, so negative 3 plus or minus root 11 is the answer. Now, when we solve the quadratic formula, over the years I used to teach people just to go ahead and plug into the formula, but this is where you turkeys make majority of your mistake. So after you've gotten everything into standard form and you identify A, B, and C, I tell my students to identify negative B, B squared, and 2A. Once you know this, I then want you to evaluate b squared minus 4ac and find its square root, and then we'll substitute. So here's my equation. A is 1, b is 2, c is negative 24. So negative b is negative 2, b squared is 4, twice a is 2. B squared minus 4ac, I always plug and chug and show the work, because this is where you make stupid sign errors, teachers included. And we get 100, and the square root of 100 is 10. I'm now ready, because I know negative b, I know 2a, and I know the square root. So negative b is negative 2, the square root was 10, and 2a was 2. So I do the arithmetic, and I showed it over on the aside. You're going to get an 8 and a negative 12, and you get 4 and negative 6. Yes, we could have factored that one. It was intended to be one that you would factor. Now this one can't be factored. A is 1, B is negative 8, C is negative 3. So negative b is a positive 8, b squared is a positive 64, twice a is 2. I insert in b squared minus 4ac, I get 76. 76 is 4 times 19, so the square root is 2 root 19. And I'm ready to substitute. So I insert the negative b and I get 8. I insert the square root and get 2 root 19. I insert twice a and I get 2. But notice I've circled the terms because these all reduce by 2. And so I divide by 2, and my answer is 4 plus or minus square root 19. Next one. Leading coefficient is now not 1. So negative b is positive 8. B squared is again positive 64. Twice a is now 4. B squared minus 4ac is going to give me 40. 40 is 4 times 10, so the square root's 2 root 10. So negative b is 8. So I put in my 8. The square root of b squared minus 4ac is 2 root 10, so it's there. Twice a is 4. Again, I created one to where these will all outside numbers reduce. And there's my final answer, and we usually leave it like that. Yes, you can write it as 2 plus square root 2 over 2. That's fine. So now, solving radical equations. First, we usually isolate and put them in exponential form, or at least think exponential form. We raise each side to its inverse, which is the reciprocal of the power. We solve the polynomial expression. If there's still a radical expression present, we have to repeat steps 1 and 2. Now, you don't have to rewrite that to the 1/2 power. You just have to know that a square root's exponent is 1/2. And so how do I undo a square root? Its inverse is to square. Notice the inverse of a 1/2 is a 2. So I squared both sides. What do you turkeys forget? You forget first times last times 2. It's not x squared minus 9. I end up with this expression. I go ahead and factor and solve. I get 2 and 7. But the key thing is that a square root must be positive or 0. So I say, what is the 2 plus 3? It's 5. That's positive. What's 5 plus 3? That's 8. It's positive. So both 2 and 5 are legal solutions for this equation. I go to the next one. Again, you can leave it a square root. It's okay. But notice when you see the 1/2, you realize, oh yes, the inverse is 2. It's the reciprocal. I square both sides. I move over. Yes, I gave you one where a is not 1. So I notice which factors of 63 subtract and give me 2 were 9 and 7. I do my grouping and end up with x plus 1 and 9x minus 7. Again, you should be able to tell me without showing any work, negative 1 and 7/9. But now I need to check. Up here, the square root, this number must be positive or 0. When I substitute negative 1, I get negative 3, which is illegal, called extraneous. And when I insert 7/9, I get a positive answer, which is legal. So my only answer is 7/9. Now we're going to do 2, where we have to play the game twice. All right, so now I square both sides. Again, don't forget, first times last times 2. I isolate again the radical. In fact, I divide the 9 by the 6 and get 3/2. And I notice that the square root is equal to a positive already, so I'm happy. There's only one answer, and so I don't have to check this. I just have to square both sides and get 9/4. Now the super duper messy one. I need to square both sides, but notice first times last times 2. I isolate the radical. In this case, I go ahead and divide by 2. And when I divide it by 2, it makes it a simpler expression, but there's still a radical. So I square, don't forget, first times last times 2. I reorganize it and factor the trinomial, and I get 1 and 8. But now let's look up here. What does the radical need to equal? This needs to be a positive number. So negative 1 plus 3 is 2. So the 1 works. Now I'm going to insert 8. Negative 8 plus 3 is negative 5. I'm very sad. That's me crying. And so I have to throw out the answer 8. It's extraneous, illegal, so only 1 works. Now, what happens if we start out with fractional exponents? Well, that's really easy. We just use the reciprocal of the x and exponentiate both sides. Now, remember, what does this mean? It means the cube root of 27 is 3 and squared is 9. And then I have to do the additive inverse of -1. So 1 plus 9 is 10. This next one is most evil. Yes, it belongs down there with Satan. This is one of his favorite problems. You come here, you blindly just use 3/2, and most people just say 16 to the 3/2. But au contraire, Pierre, you cannot do that. Because notice this little 2 down there really tells me I'm taking a square root. And when you take the square root of an even quantity and you're solving an equation, notice this is a variable, not a number. You need plus or minus. So notice that's why it makes it most evil. The square root of 16 is 4 and cubed is 64. So it's plus or minus 64. And so then I use the additive inverse of -1. And 1 plus or minus 64 gives me these two lovely answers. Now, once again, we just have 2 more boards, so this is a little nicer. Last section, a couple of these sections are long, but many of them will be short. So I want to solve a radical equation. I'm going to factor each denominator. I'm going to find the lowest common denominator. I'm going to determine the domain. I'm going to multiply by the lowest common denominator. Liar, liar. I'm going to play what's missing. I'm going to solve the resulting equation. And always, 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 the reason for finding the domain is so that we can find extraneous roots if there are any. I did not give you any on these because we'd already had a few. So notice, as always, I write it as plus the opposite. These are teacher-made problems, so usually these two are what is going to be the factors of the other ones. So my lowest common denominator is x plus 4 and x minus 1. I see my domain doesn't allow -4 and 1. I'm going to multiply through by the common denominator, but really it's what's missing. The 3 needs an x plus 1, the -2 gets the x plus 4, and the 1's denominator needs nothing. So its numerator gets nothing. I solve, I get 6. 6 is not there, and so 6 is my solution. Next one, I was too lazy to rewrite that again, so I just showed you it said equal 3. Remember, everybody needs a denominator, so it's over 1. So the common denominator is x minus 1, x plus 6. The domain is not 1, not -6. So the x minus 1's numerator needs x plus 6. The x plus 6's numerator needs x minus 1. And the 1's numerator needs everybody. So on the left, your teacher would have gone ahead and multiplied through this. I would have gotten that, and I would have combined that to get 2x squared minus 5x minus 18. I would then move to the other side. I would multiply the polynomials and get x squared plus 5x minus 6, then distribute the 3. Now I get everything organized by using the additive inverse, so it's all on the left side, and I have x squared plus 20x equals 0. I factor and solve, and I have 0 and -20. Neither one are bad guys, so no extraneous answers. Now something very simple, an Algebra 1 linear absolute value expression problem. Remember, the absolute value of blah is plus or minus 0 only. Those are the only possible answers. So whenever you see blah equals stuff, meaning a positive number or 0, you take plus or minus the number. So x minus 3 equals 10 means the inside had to equal 10 or -10. And I use the additive inverse pretty easy. Now here's where I don't understand what some people do. This is a very easy problem. What do we know? The inside has to be plus or minus 15. You should be able to do a 2-step problem in your head using the old noggin without any issues. What am I supposed to do? Subtract 9, divide by 6. Subtract 9, divide by 6. Notice I showed subtract 9, divide by 6. Show as much work as you want, but please don't write two separate equations and go back like you're sitting back in Algebra 1 again. Please, folks, please, please, please buy into pattern. So endeth the next one.